The first part of this, Ira, is a summary of everything we've done so far. So if you're looking for a handy-dandy, this is a page I should make sure I understand as I'm getting ready to understand it and write the test, which will be not next week, but the week after. Some obvious stuff. When we launch an object into the air, we call it a projectile. Projectiles travel in a parabola, but analyzing that is tricky. It's much easier to use vectors. We're going to break each projectile's velocity into horizontal and vertical components. That's the t-table. If there's an angle, this is a job for components, but if there's a projectile also, I got to be honest, this is a job for components, but we'll just say do it a t-table. So example 1 says, break the following velocity vector into its vertical and horizontal components. So let's go like this. We'll call that Vx. We'll call that Vy. I would probably remind myself that Vy is changing, so I just, as a habit, call it Vy initial and Vx not initial, because what's the horizontal acceleration for a projectile? 0. Vertical acceleration, negative 9.8. Tato, that 24, opposite adjacent or hypotenuse. How about Vy initial? Okay, Vx, which trig function? Cos. Do you see it? A and H? In fact, have you noticed the pattern, Gurjot? I think it's going to be 24 times the cosine of 36. If you sit and do the trig, you'll find it's the hypotenuse times the cos of the angle. And I think you'll find Vy is 24 sine 36. Vy will be sine... as long as you always draw the horizontal and then the vertical, which is why you'll never see me, unless I absolutely have to, you'll never see me go this way and then that way. Why would I introduce a second way to do things? Now, sometimes, just based on the way the diagram is given, especially if it's a river question or an airplane question, and you have no choice in where you put the angle, you got to put the angle where they tell you to put the angle, you might not be able to draw the horizontal first, in which case do the trig carefully. Is that all right? Welcome back. What'd you get? 24 cos 36. And if I was just asking for this, I would go to 3 sig figs, 19.4. If I knew I was going to be using this, I'd write down some extra sig figs somewhere. But since they're asking for this, I'll go 19.4. Meters per second. And... I may leave this touch screen on after all. 14.1? I just got to learn how to write without moving the screen around. Key ideas as well. Here's a summary of what we said so far. Horizontal motion, Vx is constant. Why? Because Ax is 0. That means, by the way, horizontally, d equals vit plus a half at squared just becomes dx equals vxt. That's really nice. If you ever get a chance to solve for time horizontally, you're smiling because the quadratic term, the squared, the one that's going to bite us today, which is going to force us to use the quadratic formula, vanishes if you're dealing with it horizontally. So if you're lucky, Chang, if you're dealing with a question and they give you the range, the horizontal distance, no, on the test I won't give you the range. I'll give you the height and make you do it the tougher way. I saw already somebody asking, well, you give us the range on the... No, make you do it the tough way. This means that if you know the time of flight, you can find the horizontal distance or the range, or, if you know the range and the horizontal velocity, which is either going to be horizontally from a cliff, they told you, or Vx, the component, you can find t really easily. You'll get t equals dx over vx. Do you guys have a little square on the letter G like mine does? Yeah. Okay, I got to figure out what that is. Things like that drive me crazy. I'll have to go and retype this. Vertically, Vy changes, but A is a constant. It's negative 9.8 meters per second squared. So horizontally, Ax is 0, so Vx is constant. Vertically, AY is constant, negative 9.8, so VY is changing constantly. Oh, I shouldn't say constantly in the word. Changing always. There, that was confusing because I just compared constant and changing and used it in the same sentence. So, this is the case. Which means, unfortunately, if you're trying to find T, well, if this cancels, if Vy initial is 0, like horizontally from a cliff, then you'll have a half AT squared times by 2 divided by A square root. We did that. But if you have an initial vertical velocity, you get a T and a T squared. You can't get the T by itself. The only way to solve that is, now this is a full-blown quadratic equation. You're going to have to get everything equal to 0, and you're going to have to use the T equals negative B plus or minus the square root of B squared minus 4ACL over 2A. Note, at the top of its arc, Vy is 0. Does this mean that the overall velocity is 0? In fact, at the top of its arc for a split second, the overall velocity is just whatever your vertical component is for a split second. That might be handy, I don't know, but anything I can use to save myself some work by being clever. Also, if we start from ground level and end at ground level, what goes up must come down. Vy initial will be negative Vy final. Last, if you're starting from a vertical height, from a cliff, the ground is below you, so that means you're going to have to make dy negative. The height that they give you, you'll have to include the negative. Usually you'll get a calculator error if you forget that step, but not always if you're using the quadratic formula. You might get some weird roots that work. Let's jump on in. Oh, Mr. Duck, you said that projectiles travel in a parabolic path, but I've seen some weird projectiles that when you throw them and spin them, it looks like they wobble. For example, if I toss a tennis racket and give it a spin, it looks like it wobbles. Okay, put your pencils down, look up. All right, here it is. Projectiles from cliffs at angles. We're going to spend most of our time finding time. If they give you time, I'm telling you, the question falls apart. So there are going to be some on your review where they give you the time. I don't even know if I'm going to do an example like that with you. I'm going to gamble and say, oh, you'll figure it out, because now T goes in both columns. You have your T table. You got time in both columns. You got 3 things in both columns. Go to town. Just don't put horizontals into verticals and verticals into horizontals. Finding time when they give you a height is the most difficult. There are several strategies. One strategy is to find the time to get to the top, because at the top you know Vy final is 0. Then pretend Vy initial is 0. Find the time to get to the bottom and add them up. Strategy 2 is do it all at once. Strategy 3 would be time to top, because Vy final will be 0. Double it, that'll give you time to bottom. And then right here, Vy initial is negative Vy initial here. Figure out the time to fall the rest of the way. And add all 3 up. I'm not wild about those. But if you really want to see me during a flex block, I can show you any of those methods if you're not wrapping your brain around strategy 2. But of course, Chang, you know I'm going to take the one that's the least amount of work. Even if it's the more difficult method, it's less work. And I'm willing to exert my brain to save time. See, I did that to save time? Nothing. Okay. Wow. Here's an example. You want your calculator out and in front of you. You may want your formula sheet, but I'm going to tell you right now, we're going to be using d equals vit plus a half at squared, vf equals vi plus at, and vf squared equals vi squared plus 2ad as a hack workaround if we need to. Weil, what does part A want me to find?
Time to top.
Okay. Is this a projectile? Say yes.
Yes.
This is going to be a job for a T-table. So the very first thing that I'm going to do is this. And I'm going to put an H there and a V there. And I'm going to put AX equals what while?
0.
And I'm going to put AY equals what while?
-9.8.
Everything else depends on the question. But those we'll call our physics no-brainers. You got to know some physics, but once you do, hopefully I've convinced you that that makes sense. While, look at the picture. Do you see an angle? This is a job for? Okay? I'm trying to teach you how my brain handles these. These are all my brain triggers. So I'm going to take that 30 and I'm going to say, okay, I'm going to break it up into horizontal and vertical. I'll call this Vx. I'll call this Vy initial. By the way, this 30-degree angle we would call above the horizontal. We would not call it north of east because straight up is not north. So we're always looking at the side in these pictures. We would say above the horizontal. If instead of launching it 30 degrees upwards, if I wanted to launch it 30 degrees downwards, which is an angle of depression, we call that below the horizontal. But that's the phrase. If you're looking to give an answer direction of a theta, that's how you can describe it. Hypotenuse, adjacent, opposite. Yeah. While, what do you want to find first, Vx or Vy? I'm going to give you a hint. For this one, find Vx first, and you'll see why later. Okay? Which trig function? Cos it is. In fact, I think it's going to end up being 50 cos 30. I know the cosine of 30 is 0.866. Can I multiply that in my head? I'm going to need a calculator. Did they specifically ask for this, or am I using this to find something else? I'm using this to find something else. I'll carry extra sig figs. Now, you can write it up there. Typically, once I have it on my calculator, I just drop it into my T-table. I'm going to go 43.301. Vx equals 43.301. You can put units or not. I'm often sloppy with units in my notation. I'm fussy with units at the very end, right? So it's up to you. Vy, while which trig function? And this is exactly 25, yes? I know sine of 30 is 0.5. I know cos of 30 is 0.866. Something. So I can say Vy initial is 25 even. If it didn't work out evenly, then Alec, I'd carry extra sig figs. Right now, I only have 2 things in each column. How many things do I need to solve, Taylor? Where's the third thing, Weil? What else did the picture tell me? Okay, so I'll call that dy. What am I going to write? Yes. Now, I'm going to move out of my vertical column to show you we have a couple of options, okay? First of all, I'm looking for an equation that has an A, a VI, a D, and a T in it. There is one. Which one, my friend? Yep. And I think I said the other day, this is the one we're going to be using like 85, 90% of the time coming out of here. So I can use D equals VIT plus 1/2 AT squared. In your mind, kind of draw a line down the middle of the page because I'm going to show you an alternative hack workaround method on the other side here. I'm going to tailor just to reinforce, put a Y, make sure I don't put a horizontal into a vertical. By the way, the most common mistake here, when kids see VI, they want to put the 50. Isn't that the initial velocity? We're never going to use the slanty. Just banish that from your mind. Once we've done components, I don't even look at that slanty anymore. But the reason that's so common an error is it's almost always a nice round number, and the kids, I want to use that number, right? So when I do this, I'll get negative 60 equals 25t minus 4.9 t squared. I did the half of 9.8 in my head. Is that okay, Kieran? Okay. What kind of an equation is this? It's a quadratic. And this is something you should also bring if you're in pre-calc. What kind of an equation is this? It's a quadratic. How do I know it's a quadratic at a glance just by looking at it? The t has a squared on it. Now, the t has had a squared on it last year. This is a yuckier quadratic because not only is there a t with a squared, there's a t with an invisible 1, what we call a linear term. This is a full-blown quadratic, and the only way to solve this is with the quadratic formula. How do you solve a quadratic? What was the first thing that you always had to do before you even started? Make it equal to? Now, I have a preference. This is me. This is a Mr. Dewick avoiding dumb mistakes. I have learned over the years that I make more mistakes when the squared quadratic term is negative. Even though it would be less work, Sarah, to go plus 60, since I'm doing it all in my head, I'm actually going to plus this here, minus that there, because I much prefer my quadratic term to be positive. I've just learned I make fewer dumb mistakes that way. That's not a rule you'll see in any textbook, Chang. That's me. Okay? So I'm going to say positive 4.9 t squared minus 25t minus 60 equals 0. For a candy, without looking at their formula sheet, who can tell me the quadratic formula? Linnea. Nope. Alec. Squared. X equals negative b plus minus square root b squared minus 4ac over 2a. Anybody say it faster than that? Anyone say it backwards? A2 overall. CA4 minus square b root square negative plus b, minus plus b negative equals x. I love, and you know I'm a nerd. Really? The quadratic formula, when I taught math, I would tell my students it was almost as close as we got to Shakespeare in mathematics. I would say this is like iambic pentameter at its fullest because it's the only one of its kind. We've known about the quadratic formula for solving any equation with a squared in it for 800 or 900 years, quite a while. And as soon as they found that one, it led to a question in mathematics. Is there a cubic formula? Is there a quartic formula? Is there a one ring to bind them all, ring of power formula that will solve any power? And hundreds of years were spent searching, and it was only, I think, at the beginning of the 1800s when a mathematician proved there is not only, and it was a complicated proof, only the quadratic exists. There is no one-size-fits-all cubic. There is no one-size-fits-all quartic. There is no one-size-fits-all quintic. Who's doing calculus this year? So what you'll learn sometime March is what's called Newton's method. That will solve any equation by making a guess and then using that guess to make a better guess and then using that guess to make a better guess. And within about 4 guesses, you're already accurate to about 8 sig figs. How accurate do you want to be? That's how your graphing calculators solve equations. They use a numerical approximation. They go to 99 decimal places, which is as accurate as you'll need to be, which is why you think they're exact values. They're not. They're rounding off still too. But this is the only one of its kind. Alec gets his candy. The rest of you, I did put it on your formula sheet. I think it's in the same section where you see the triangles and stuff like that. Yes? So, let's write it down. If you wrote x equals, I won't take marks off, but technically we're solving not for x, but for what? T. So, as a pedantic nerd, I'm going to go t equals negative b plus or minus the square root of b squared minus 4ac all over 2a. I need to double check. Do I have any international students from Europe here? Okay, no. There is another variation of this that uses a totally different method but does the same thing, and they typically teach it in Europe. You've had me before, Chang. Organized but lazy? Yes. So I'm going to go like this. A, B, and C. Who has a quadratic solver? As far as I'm concerned, you can quit right now, and you can go straight to finding what t is. Now, do you know how to use your solver? If not, I'll help you later on in class. The rest of us, sadly, are going to have to go like this. T equals positive 25 plus or minus the square root of 25 squared, that's 625, minus 4 times negative positive 4.9, negative 60, all over positive 9.8. I need more room, so I'm going to do something that you folks can't do, and I apologize, but wasn't that cool? Mr. Dewick, I had trouble with the quadratic formula last year. If I can give you one tiny piece of advice, if you are doing this without a solver on your calculator, I'll call doing it on your calculator by hand. What I mean by that is having to type everything in. I typically would do the square root first. I would say, what's inside the square root? 625, or b squared, minus 4 times 4.9 times negative 60. I would rewrite this very quickly as t equals 25 plus or minus the square root of 1801 divided by 9.8. If you are good at getting this right and just backspacing and editing, that's great, because then you can go to your calculator, you can go bracket 25 plus the square root of 1801. I have to close off the square root, close off the top, divided by 9.8. There's one answer. And then, really, this is one of the main reasons I went on my calculator rant last year. The fact, if you can backspace and just change that to a minus sign, there's your second answer. Those of you that have the solver, you also get 6.881, blah, 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 and negative 1.7794. Yes? Let's write those down. T equals 6.8814 and negative 1.779. With a quadratic equation, you'll always get two roots. But now we have to come back to our physics world, because the quadratic equation is abstract mathematics. We weren't solving for x. What were we solving for, Tato? Can time be negative? So we reject this. Much like when you ask a girl on a date. Reject. People on YouTube, what? I love him. We're all good. I get some weird comments on YouTube. You're really mean to your students. You got to be in my class. It's all in love. Dumb ways to remember things. Those of you that got the solver got that as well, yes? Now, if you are shaky on the quadratic formula, how many of you feel comfortable with the quadratic formula, by the way? Raise your hand. Okay. If you are not, there's a hack workaround. I'll show it to you. That's what the second column is for. And I can't help noticing I have 1, 2, 3 things in the vertical column. There's something else I can solve for instead of time. Instead of solving for time, I could solve for Vy final. That's going to be how fast it's going when it hits the ground, which is not going to be negative 25. It'll be going negative 25 when it comes back to the same height as the cliff, but it's going to be going fast. In fact, I can already tell you Vy final is going to be larger than negative 25. I'm looking for an equation, and it has V final, V initial, D, and A in it. There is one. The squared. So I think we're going to get this. Vf squared equals VI squared plus 2AD vertical, vertical, vertical. And Ange, how to get rid of a squared? Okay. If we do this, we'll get 25 squared plus 2 negative 9.8 negative 60 square root. (25 squared plus 2 times negative 9.8 times negative 60). By the way, see the 1801? You can see we're doing parts of the quadratic formula in chunks using this method. And I get 42.4382, which must be wrong. Why must that be wrong? Has to be negative. The weakness with this method is we have to add the negative after the fact because your calculator assumes you want the positive square root, but this time we know we want the negative square root. So I did two hands. Oh, there we go. Vy final is negative. I have to add that 42.4382. But now, Ange, I can find time. There is an equation that has a V final, a V initial, and an A. Skip the D and T. Which one? I think you're right. I couldn't hear. Get the T by itself. And if I go, bracket, negative answer button, that's how I make my velocity negative. Isn't that clever? Minus V initial divided by negative 9.8. And you'll notice I actually get it to the same number of sig figs as the other method. I'll take either of those, Taylor. I'm fine with either of those. In fact, I flip-flop. If I happen to have my graphing calculator when I'm making up an answer key, it's got a built-in quadratic solver.
How do you get the negative 1.7 for the second version of the chapter?
Are you using a solver?
No. I was just wondering because the VY final version, how do you get the...
Here? You're talking
like,
here?
Yeah, you see how like this...
From this method. How would you get the... Is that what you would get if you didn't make the velocity negative? That's a good question. What if we just went 438 minus... You're the first kid to ask me that. Candy for asking a brand new question. I wonder if that'll give us the negative time. Yeah. So that would be an impossible universe where things that are accelerating downwards in the negative direction somehow have a positive velocity. Okay? Second candy for you. As I was saying, though, if I happen to have my quadratic solver on me, I'll use the quadratic formula method. If I'm just using a regular scientific calculator and I'm in a rush, I've gotten good enough at finding V final showing no work and then using that to find time showing no work that I can give you T showing no work, writing nothing down, just with a good calculator, so I tend to use that method. I flip-flop. Whichever method you want, but you have to be able to find time. What did we just find? What did we spend most of our time finding? The question's going to fall apart. What does B want me to find? First of all, we're going to come back to B. What does C want me to find? dx equals vxt. Plus a half at squared, except what's a horizontally? Nothing. Well, I've turned the page. What was vx? 43.3012. And time was 6.8814. One line and we're done. Lots of lines to find time, but once you know time, question tends to fall apart. 43.3012 times 6.8814. I might keep the touch screen on because this is really handy to be able to type on my calculator. 298? 297, 3 sig figs, 298? Meters. By the way, this bit of math that we're doing by hand, this is one of the main reasons computers were invented in World War II. To do the quadratic formula before we had calculators, to do that square root, you used slide rules, and you could do it by hand, but it took some time. And at the time, the strategy was, if you were the Axis Germans or you were the European allies, you knew roughly how long it took to make the calculation to send it back to the headquarters, so that now the headquarters would know what angle to raise their guns at so that the shells would land where you are. So you would just move before that happened. You had it timed quite nicely. So once computers were invented, now spotters at the front could say, well, the enemy is this far from us, and within about 30 seconds from headquarters, they could say, okay, you want to aim your gun 28.6 degrees. That'll get them. Now that whole, we'll just move every so often and make us hard to hit didn't work. So, computers. Killing people since they were invented. Sorry. Time to top. Did I say top? What do we know about the top? First of all, the word top. Vertical or horizontal? Okay. I think I made fun of Chang last time. Something about never, okay, you can imagine you've had some success and you're finally at the top, right? What else do we know about being at the top? Okay. I've changed pages, so I'll write everything else. VY initial was 25, AY was negative 9.8, find T equals, and you can see this is fairly pedestrian. This is physics 11 now. This isn't anything fancy schmancy. We've done a bunch of these. We're just getting better at dividing our brains two-dimensionally and realizing I'm going to solve things horizontally, I'm going to solve things vertically, I'm never going to use the slanty, and just be careful I put what's what. I think, Ange, we can use exactly the same equation you gave us a few minutes ago. T is going to be VF minus VI all over A. Whoa. Maybe I will turn off touchscreen. Let's see. VF. Oh, it's going to be really close to 2.5, 2.6? Something like that. 2.55? Because it's almost 25 divided by 10. 2.55? Now that you knew how long it took to get to the top, could you calculate how high it was? Could you find dy? Yeah. What if they wanted the total height? Then you would also add the height of the cliff. That would tell you how high it was above the ground, because all this will tell you is how high it is above from where you started from. Other questions that I'll throw at you, okay? Put a little star next to D. This is the tricky one. This is also the same as question 5B from last day's homework. Question 5 from last day's homework, where it was asking you to find a velocity. Sarah, can you read to me D? What does it say? I'm going to draw it. I'm going to dollop. I think the impact velocity looks something like that. It might be steeper. It might be shallower, but I'm telling you, it's hitting the ground at an angle. Did I say angle? This is a job 4. Okay. I'm going to try drawing the horizontal first. So it's going to look like this. And I guess instead of VY initial, I'll call it VY final. Wait a minute. I know VX, because that never changes. That was 40, what was it? VY final is not 0. It's 0 after you hit the ground. VY final would be solving for VY final vertically. And Ange, I think we already did that. We already found that VY final was what? Now, the arrow already contains the negative because it's pointing down. So on my diagram, I'm not going to label a side as being negative. I'll show negatives and positives with arrows. So what was it? 40 point. Give me more sig figs if you can. Did I not write them down? Negative 42.4382. And I can now find the impact. How will I find the magnitude? I'm looking for a word that begins with the letter P. Come on, people. It's Math 8. Pythagoras. And then theta always goes where the vector is originating from. So the magnitude of the impact velocity is going to be 43.3012 squared plus 42.4382 squared equals square root answer button 60.6. Sorry? Am I wrong? Ready? It's negative because of that. There's the negative. It's in the diagram. Typically, we don't label negatives on our vector diagrams. We label negatives with the arrows in our vector diagrams. Was it 60.6? Is that right?
Yeah.
Meters per second at. By the way, I noticed these two sides are almost exactly the same length. Theta is going to be really close to 45 degrees. Yeah.
You asked for impact velocity. That always
I asked for impact velocity, not speed. Velocity, is that a vector? All vectors have both what? Magnitude and? Okay. Now, if it was a test, I might cue you and say in brackets, magnitude and direction, but I'll try and make the homework tougher. So we're going to find theta. It's going to be really close to 45, I'm pretty sure. Adjacent, opposite. Hey, which trig function? Tan again. Opposite 42.4382 over 43.3012. $42.4382 over 43.3012. Oh, I totally typed that in wrong. I missed a decimal. That'll do it. Insert a decimal. That totally didn't work. Insert 4382, and then I want to nuke this 8 there. You get 44.4? I told you, really close to 45. Direction. Now, if you called that south of east, I would not take marks off, but I would also say to you, Taylor, that down is not south, and up is not north. So we would describe this as below the horizontal. Example 2. Find the flight time, find the range. Let's walk through our... Am I wrong, Kieran? No? Oh, I thought you were looking like you had a question. No? Flashcards are good there? Test coming up? Okay. Find the flight time, find the range. Sharon, is this a projectile? So we're going to go T-table. Write down our physics no-brainers. Sharon, do you say angles? Do you see angles? This is the job 4, components. So we're going to take that 35 at 20 degrees. And we're going to break it up into Vx and Vy initial. This is a bit small. I might even have redrawn this. I'm almost wishing I had, giving myself a bigger line to work with. Where there's the hypotenuse, there's the adjacent, there's the opposite. What do you want to find first, vertical or horizontal? Doesn't matter. Vertical? I think sine. Yeah. So Vy initial ends up being 35 sine 20. And I think, Sharon, Vx is going to end up being 35 cos 20. Of course it is. $35 sine 20. 11.9707. $35 cos 20. 32.8892. What else do I know, Sharon, my joy? Look at the picture. There's something else I know. Which D? You're doing this. Can you use a word that begins with the letter H or a word that begins with the letter V? Can you use a word that begins with the letter H or a word that begins with the letter V? Can you use a word that begins with the letter H or a word that begins with the letter... This is what I'm really trying to emphasize. Don't even think height. Think, is it going to go vertical or horizontal? I put it in the right place. And why is this wrong, Sharon, my joy? Because it is. Yeah, why is that wrong? So, what do I need to put? Yes, thank you. Which column do we know 3 things? So, I'm going to pause. I'm going to freeze the screen. Your job is to find time any way that you wish. I'm going to very quickly do it on my solver just to let you know what you should get, I think. Let's see, it's going to be... Really, this solver is terrible. But it'll work. I think you'll get 3.5824 seconds, but I did that showing no work whatsoever. I might be wrong. Now I'm going to do the work. I'm going to freeze the screen. You folks can do the work as well. See if we end up in the same location. Quadratic formula. Sure, Mr. Duke. Let's go. Quadratic formula. Uh-oh, I might have made a mistake. Let me double check my solver. I might have made a mistake in my typing. I think that's what I did. 11 point... Oh, geez, do it. It's negative b. No, that works. Negative b is going to become positive. Plus or minus the square root of b. I missed the squared. Sheesh. That was silly. Oh, I don't feel so bad. Linnea missed the squared too when she called it out. I got those two time values, I think. Now, if you're having trouble finding t, I don't have time, no pun intended, to reteach Math 11 quadratic equation solving in my class. Then you need to hit me up during a flex block and we'll do just a whole bunch of practice ones until you get good at your calculator. Because 99% of the time, it's typing this into your calculator. And if you get good, great. I'm going to encourage you probably to get comfortable using the quadratic formula because it'll come in handy. Actually, this is only the answer to part A. What did part B want me to find, Brian? Oh, good gosh. B. dx equals vxt. It's almost anticlimactic. It's like all the work. I spent most of my time finding what? What was vx? I've scrolled down, Brian. What was it?
32.89.
I need a bit more room, Mr. Duke. dx equals 32.889 times 3.582 32.889 times 3.58237, and I get 118 meters, 117.8, 118 meters. I tried to fit this all on one page so I can keep it on one screen. I think I gave you like a whole blank half of a page to do work. Don't be scared to use up some space and write big and organized. Am I right? I should have asked. Everybody else get the same time value? Yeah? Okay. Wow, I left like a... No, I'm missing stuff now, aren't I? Is there like a page and a half of blankness? No, I think for some reason I've suddenly lost the lesson. Let me come back here. Okay. Where's the next thing? Blank page, blank page, blank page. Wow, did I include a whole bunch of blank pages accidentally? You guys don't have that. No, I've lost everything. What the heck? Okay, this is strange. Well, thankfully, I had planned on pausing here. What does it say? Example 3?
Yeah.
Okay, so we're going to go like this. but on the very, very bottom, at the very end of the lesson, where there's homework, from the can you copy this down where there's homework, please? From the ultimate review, you can put a star next to those questions there. Those I consider to be tougher than I'm going to ask on the test. But your homework right now is you can now do every question on the ultimate review. You can start it. It's due the day of the test, which is not next week but the week after, so don't freak out. We'll finish this lesson off next class. I'll give you a couple of thought experiments as well, and then I'll try and figure out what happened to my other stuff.